Hello, everybody. Thank you for joining this next webinar on the IP knowledge and context of the public address and voice alarm system PRAESENSA. So as you see on the next slide, this has been a full series of IP topics. We've went through the network introduction, the basics, audio connections, RTSP hop count, real-time audio and security arrangements. And this is actually the final session in the total pack where we talk about network requirements and considerations for PRAESENSA running on an IP network. As you see on the next slide, so today the objective of the presentation is to provide you more insights on the network protocols described in the chapter 4.6, where all the network requirements and considerations are listed for PRAESENSA. We will run through the chapter. We talk a little bit about system size limits, network switches, and interfacing with corporate networks. And today myself, Maarten Wings, I'm hosting the webinar together with my colleague, Anton Thiele, who is application engineer for public address and voice alarm, who will talk you through all the details. Anton, please go ahead.
Yeah, thank you for the introduction, Maarten. Chapter 4.6, Maarten already mentioned it. That's an important part of the installation manual of PRAESENSA. It's about network requirements and considerations. And that's also where this webinar is about. We're going to highlight some of these topics. You can find the details there, and also some aspects already discussed also in earlier sessions of this IP knowledge series. So I really recommend to have a look into this chapter and share and discuss this documentation with your customers again, with the IT technicians, and if you're yourself the IT technician, please have a look and be sure that that these requirements are aligned with the needs for PRAESENSA. So in a nutshell, what has been explained earlier in other sessions are the bandwidth requirements. We have 3 megabit per channel. That's about what you can calculate for the network requirements for PRAESENSA. As you might know, we are using multicast there for all channels, so that means you can just calculate that every channel will add a load of about 3 megabit per channel when you activate that. So for a background music channel would then cost you 3 megabit. If you have a second one, in total you have 6 megabit of traffic going on. Yeah, so that's the thing which you should keep in mind. Another one which we also discussed before is the maximum latency between source and destination. We have set our play out time in the PRAESENSA equipment to 10 milliseconds. And we always state that we would like to have 50% of the that you are within 50% of the stated time that you have the packets brought from A to B. So your maximum network latency, we're talking about network latency between the source and destination, should be then about 50%, which means smaller than 5 milliseconds in that case. The jitter, the variation of this latency, should also not deviate too much. That has to do with the timing, with the PTP, Precision Time Protocol we're using to have all audio fully synchronized over all the different components in the network. And for that, we need to have not too much jitter variation in this latency. Switches must be gigabit, and they must support packet switching in hardware. That's the most easy way. You can have some exceptions to have end devices on 100 megabit, but then you need to do something with quality of service. So the easiest way is to use gigabit, and to then it's more or less plug and play in this case. The network is running on rapid spanning tree to avoid to create loops in the network, and we support to create loops to be able to have redundant connections. It's different from, for example, the standard Dante devices from Ordinate, where you can have not the ability to create a loop. So you always need to have then a point to point. You can have two parallel networks, but it's in this case you can really create loops, and in PRAESENSA. But for that we are using this RSTP rapid spanning tree protocol, which we discussed also earlier. And we adjusted these parameters, these rapid spanning tree parameters, for smooth firmware updates. That means the timers are slightly adjusted on that. That's also mentioned here in this 4.6 chapter. Yeah, furthermore now, the link layer discovery protocol, that's recommended to be enabled for network supervision. So we're using that standard LLDP to do this. Yeah, proper quality of service with strict priority through diffserv. That's something which can be especially useful in case you have a larger network and some accepted components which have only 100 megabit. Another aspect is to not use energy efficient Ethernet. The reason why is that the ports fall back to a lower frequency, and then at the moment that traffic arrives, then it goes to the higher speed, which consumes then slightly more power. But at that moment, yeah, you introduce this jitter. So because it takes time for the port to activate, and yeah, so then you get, if a packet just was just entering the switch and then or the device, then yeah, that would yeah, need to wait until the port is active. That's the reason why we do not use this. And in comparison with the application we do, this energy efficient is almost nothing. So switch it off. Then make sure that jumbo frames are not present on the network. Yeah, so we do not support jumbo frames, and disable IGMP snooping in network paths between PRAESENSA devices. This is also important, especially for switches which are not that quick to handle this. For example, our own ES-AP2S Advantech switch, which we use also and which is certified in the network to interconnect PRAESENSA devices. You can use it as a device to connect to external components. Then you can activate the IGMP snooping. But if that switch is inside the PRAESENSA network itself, the snooping algorithm is not quick enough sometimes maybe to filter out the multicast. Yeah, so so that's something which you should disable then in that case. Yeah. But also on our default devices, this is not enabled. So if you just use the default configuration, then you do not have to take care of all these things. That's all in these Advantech switches, that's all managed. Yeah. So that are the network requirements and considerations of the chapter 4.6. So a little bit more on that link layer, what I initially mentioned there. We have the LLDP must be enabled. So, and that is the protocol to advertise its identity or capabilities to its neighbor. And PRAESENSA uses this LLDP for network supervision. And we have in PRAESENSA a network supervision option to detect which ports are connected in my PRAESENSA network, and do I still have connection to the other devices. And if so, it's using for this the LLDP. So if you have a switch in the network where the LLDP will be disabled, yeah, then it is not able for the PRAESENSA system to create a network image. We also have another tool which is called Network Docents. You see here a screenshot of it. This is a free tool which you can download from the Bosch website, which can do some network monitoring. It can do monitoring of PRAESENSA devices, but also standard SNMP supported devices. And it's using, besides for the Omnio devices, our own OCA, our control architecture control protocol. It's also using, it can use SNMP and in this case LLDP, the link layer discovery protocol, to create the network map and to indicate on which ports which devices are connected. Yeah, so for that you need this LDP to be enabled. Now the proper quality of service with strict priority through DivServ, differential services. Yeah, QoS means quality of service. Differentiated services, it's mentioned here. So ensure that the PTP, the clock synchronization, precision time protocol is this PTP standing for, the clock synchronization and audio packets get priority over control packets. So that's the, if you have a very over dimensioned network, this would not be directly required, because then you are always sure that your packets are arriving at the right moment. But yeah, if you have some higher load on your network, yeah, then it becomes important that you activate the quality of service. Yeah, and that quality of service works through strict priority through differentiated services on all ports. So that means that you must, yeah, so we have within the PRAESENSA system, we're using the Dante technology. And also when you would look at the Ordinate website for Dante technology, you could see that there are default priority labels, I would say. Here these codes are together sent with the packages which are sent out for the Dante communication. And that are these labels. One is then for the time critical precision time protocol. And this is then this particular label which is attached to that packet. And then for the audio, you have your EF label, and then you have for the others that's yeah, that's just then ignored. So these two are the most important ones. And if your switch now gets a high priority packet in, then it will first process that one. It will not put in the buffer. And if you have other packets which might be later, so only the time critical PTP packets will then be handled as first. Compare it with your business class ticket at the airport, where you can have your high priority handling. So you don't have to queue, you can just be walk up front, and you are then can directly enter the plane. So this is the same principle, and these are pre-defined labels. So yeah, based on that label, decide forwarding behavior. And in a quiet network, QoS will not make any differences, since it does not happen very often. There need to go packets to the same switch port. Yeah? So that's something which is then what I already mentioned, the case. So if it's over dimensioned, then it's less relevant. It gets important when you have more than 30% of your network occupied. And normally in a gigabit Ethernet network, that doesn't occur so quickly. So you do not have so quickly this 300 megabit of data going over the network. But with a 100 megabit network, yes, it could be, because then if you say, I mentioned you have 3 megabit for a channel. So if you have more than 10 channels, yeah, then with 100 megabit devices, then it might already get important. So yeah, so if you have these devices in the network, then be sure that you have set up your quality of service if you are using external switches. Our own Advantech pre-configured switch already has these quality of service in place. Yeah, do not use the EEE. I merely mentioned it, but yeah, unused ports fall back to 100 megabit. And as soon as data arrives, the speed will be scaled up again. So this will break the synchronization of the precision time protocol. And in unmanaged switches, that's maybe important. Some of these unmanaged switches, you cannot switch this off, because it's our unmanaged switches, and they have then default this EEE enabled. So you might get problems if you use an unmanaged switch which supports this EEE. Yeah, so don't use them. Make sure that jumper frames are not present, and one jumper frame can obtain up to 9,000 bytes, which then blocks the network too long for the other traffic. So that means then that frame must be handled at once. And then again, you can have that jitter too much, that the frame must wait until that jumbo frame would be past the switch. So that's something which we don't want. So be sure that they are not allowed on the network. Yeah. So that's a thing to take care of. So disable the IGMP snooping in network paths between PRAESENSA devices. And yeah, what is IGMP actually? It's the Internet Group Management Protocol, and that's an IP protocol that allows several devices to share one IP address, so they can all receive the same data. Yeah, so it's in that case, that's actually the multicast way of transferring data. Yeah, that's what this IGMP is about. And a network switch may only be aware of layer 2, so and cannot be aware of any IP or content inside the Ethernet frames. So it's like an envelope where on the outside the IP packet is inside that envelope, and so it doesn't see. A switch normally doesn't see Ethernet. It doesn't see IP. It only sees the envelope, the Ethernet frame, and so in that case, it might forward the multicast traffic to devices that don't need it. So and this is something where IGMP snooping could solve to snoop that IGMP message. So looking into the Ethernet frame, so looking into the envelope, and then enables them then in that case to identify where the multicast messages should be forwarded to, and that only the correct devices receive the multicast. So it's a kind of filter in that case. So you can imagine when you have a switch where you maybe have a very slow device, let's say in this case a 100 megabit device, and you have a lot of traffic, and you don't want that 100 megabit device to get all the channels, all the multicast traffic to be loaded on that device. And so this IGP snooping then just checks in the switch. It's the protocol which runs in the switch, and it checks if that device really needs it, and if it's maybe it needs one of all these channels, and then it will only forward the multicast of the of one of these channels to that particular device. That's what this snooping normally could solve. So it's a multicast filter. Yeah. So that's something which is done. So yeah, why then now should I disable this between PRAESENSA devices? Yeah, the performance limitations of the switch is here the issue. So while snooping many simultaneous of these IGMP messages, that may cause some messages to be dropped, and so it then cannot handle. It's not quick enough. We are using a very dynamic way of adding channels and removing channels, and every time you make a call, a new multicast channel is on the network, and yeah, then it must be filtered out immediately, and that response is also not sometimes not quick enough, or the stopping is not quick enough. So and then we would say yes, if you have static channels and static assignments, then it's not a problem. But for this dynamic behavior within the PRAESENSA devices, then it is recommended to disable this. On the Advantech switch, you can only disable this for the entire VLAN, for the entire network. So that would mean that you unfortunately cannot use that switch to say if you have done multiple devices and you have also third-party devices connected to that switch, yeah, then that third-party device should also just support the gigabit, and you cannot use the IGMP snooping. If what we recommend always is then to have a separate switch, so separate Advantech switch, where you enable the snooping, and there you can connect all your slow, I would say relatively slow devices, which cannot handle the lot of multicast. So you're using them, particularly that one brick, as a multicast filter for the slower devices. Yeah, or just design gigabit. That's the other option. So yeah, yeah. Again, back to this IGMP snooping. Using daisy chain devices will then become a problem. When you have multiple of these devices in a loop connected, yeah, then you can see these behaviors that it's not quick enough to adjust it. Exception is our non-omnio 100 megabit devices in a network with more than 20 multicast channels. So connect them each on a separate port of a switch and then activate the IGP snooping on these ports to only for these 100 megabit devices. Yeah, so that's then what I said, just have a separate switch running IGP snooping, and there you connect your 100 megabit devices. So it can only, yeah, I was a little bit ahead of explaining it when looking at the screen, but yeah, you can disable the snooping on the entire switch. So in this case, use a separate switch to connect the non-omnio 100 megabit devices. Yeah, and maybe a better example is here this FPA 5000 or Ethernet panel, which I showed here. This device really should be entirely blocked from multicast. So in that case, if you have, we can also via a separate link connect the smart safety link over IP. We can connect to our Bosch Fire panels. We should fully block it. That's also possible in that switch, but so that's then even a higher level than IGP snooping filter. Then you can say just drop all multicast. So what you then do in that case is to drop all multicast traffic. You connect this panel and then it's working perfectly. Okay, that's about the quality of service and IGP snooping. Let's now go to the system size limits. The network requirements and considerations here. You have, first of all, the maximum distance. Yeah, using synchronized player times with an accuracy of 1 microseconds. That's what we do with our system. And we're using a receive latency of 10 milliseconds. That's what I said. So you need to have, then be sure your network is compatible to bring the packets in time. So we say then design it on 5 milliseconds. At the worst case. And that would mean that you could reach a distance of 500 kilometers if you do not have too much active components in your network. That's of course, you must not only calculate the latency of the cable, but also of course of every active component which is between your source and your destination network device. The maximum number of devices and addressable zones. Yeah, so the influences the system response time. And we can have for one single presenter system 150 up to 250 devices. As you can see here also in the screen, the number of zones addressed in one call. So you can have more, you can have 1,000 zones or more. And if you say, but I never have more than 500 zones for an as a worst case call, then it's still within 1 second to to set up that call. So this is briefly how you could consider your maximum number of devices. Yeah. So if you have more zones, you can have more zones. But if you want to page them all, you want to do an all call to more than 1,000 zones, yeah, you can have a non-acceptable time before the call is set up. So it will take longer. Yeah, so it's important for this to if you have a larger system than 500, then yeah, we should come with other options. You can have then the option, for example, to use a master system with subsystems, which can then still do all the management and that still behaves as one system. So then you can scale up, but be careful. This is the boundary for one subsystem. If you have more, then you need to go to a master sub architecture. Yeah. Interfacing with corporate networks. So the next topic here is that if you want to connect your PRAESENSA system to the outside world, yeah, when you have or already are familiar with PRAESENSA, they are actually very standard devices like you could have like your own PC. So it means if there normally they are default set to auto configuration. And that means if there is no DHCP server in your network, they will jump into a link local address. It's the same like your any standard PC. I know with some corporate managed PCs, they do not allow the link local of a laptop. Then you need to set it manually. But in this case, these devices will just, these Presensor devices also will just go into a link local range. Yeah, with link local already says, yeah, you do not have a gateway. You cannot go outside. So you must have a gateway configured to be able to be managed from the from out another network in that case. Yeah. So if you say via the same VLAN, you can then interface, or you can interface through that gateway for management. Yeah. And you can also have the interconnection through a corporate network. That's also an option there. Yeah. So let's first start with a local single connection. That means you have your Presensor system, like in the link local, which I just mentioned, no gateway or router, and the customer IT network is in the same VLAN. So you just hook up your own network to the Presensor system. Be careful if you say, yeah, we allow this, but then maybe the customer says, I don't want to have any RSTP enabled, no rapid spanning tree. In that case, you must be sure that you have no loops in your network, because if you would have a loop, immediately then, yeah, this network could break down, because it's normally a default. It's not allowed to have loops in a network. So for that, to protect creating broadcast storms, we need to have this rapid spanning tree protocol RSTP enabled. So, but RSTP on can also have impact on the customer IT network. So yeah, as I said, some customer networks do not allow third-party equipment to run RSTP. Well, you can easily avoid that by putting a separate switch on top in between, or have a switch of the customer network telling, yeah, we need a switch of you, which can disable the RCP. So it's a simple BPDU filter, which is a standard feature in most every managed switch, where you can isolate the multicast, I can isolate the RSTP domain of the Presensor system from the customer network. Yeah, so that's something which you can do. We also do it here, or when we connect our Presensor system to the corporate network, we just put a switch in between, and we have here our full local network here with spanning tree, but loops, and then we connect it through a link to the customer network via that switch with the BPDU filter on board. Yeah, when you look here, Presensor is dynamically using multicast audio channels. So that means we have these IP ranges of multicast traffic, which is generated starting from this 239.255, and then you can select one of the ranges of about 400 addresses, which can be used dynamically in the Presensor system. So you have some option here to select the right range. Also, you could have multiple Presensor systems in the same network, and then you select just for your second Presensor system, you select another multicast range. So you can do that. Yeah. The corporate network, in case you connect it like this without any filter for multicast traffic, it also needs to process it. So be careful with that as well. So be sure that it can handle this. Yeah, the IP assignment was in the past link local or DHCP. We now, since 1.61, since a couple of weeks, we also support fixed IP. So that means that you can also load a fixed IP address and the gateway into the system, which then would, without any further DHCP server, would be able for you to have a gateway and to communicate to a customer IT network. So that's also possible. Yeah. Important here is that you do not have, that's something for EN54 and for the EVAC regulations, is that you do not have any audio and critical paths through the customer IT network. So you should not have here, this system have another system at another place connected to the PRAESENSA net to the customer network, and then have a microphone from here going to a loudspeaker here. Then the customer IT network is part of the critical path, yeah, and that's not compliant to the EVAC regulations. So be careful when you connect to a customer IT network, especially when you want to use the same network. Yeah, be sure that there is no critical path from that network into the PRAESENSA system. Another option is to have a router port, and normally you already do that when you connect it to a customer IT network, at least especially for monitoring. You connect it then through a router port. Yeah, that means a layer 3 connection. So that means that this device needs to have a proper IP address. So I still mentioned here a switch in between to have the DHCP service managed for your and to have the right IP address here. But now we have also the fixed IP. You would not need that particular switch to directly connect the system controller then to the router port of the customer network. So that's something which could help here. Again, no critical audio paths and control paths to the customer IT network, and yeah, not all PRAESENSA network requirements apply for the customer IT network. Now this is really isolated. So now you have also here, for example, the spelling tree, which does not go through that layer 3 connection. So now you do not need to have that BPDU filter, which I mentioned before, because this already isolates the RSTP domain when you go to layer 3. And yeah, and some more things. So like the multicast traffic, yeah, things can be automatically isolated now because you have this router port here. So RCP does not go beyond, multicast go not beyond, yeah. And PRAESENSA devices must have the gateway IP address, yeah. So that's something which is important then. And yeah, the PRAESENSA needs a local DHCP server. That was until a couple of weeks. I need still to update this presentation for that, as it now also supports the fixed IP, and then you can directly connect to the customer IT network. Yeah? Firmware updates can only be performed directly via the PRAESENSA network. That's something which is mandatory. So you must be on the local network here to do your firmware update, and it's always recommended to be more close to the equipment for such kind of activities. Yeah. Another option is a layer 3 switch in the PRAESENSA system, which is used as a router. So for example, we have certified the IE5000 Cisco switch, the 12S12P, this particular version, which can be acting as an interface to the customer network. And you can in that case also have redundant connections. So that's the IE5000 is already certified for the layer 3 switch, and yeah, other variants of brands might also work, but they are not certified or tested by us. So that's something which can keep in mind. The PRAESENSA network is fully isolated and can interface via static routing or even via dynamic routing protocols like OSPF. You can have an encrypted and secure OSPF routing connection between this, and then that means that it is part of your customer OSPF routed network. And then like any other routers which might be in your network, you can connect on this device also as your interface to the customer network. Yeah. Or maybe also via another link. So you have then multiple redundant connections which can connect to the PRAESENSA system. And from there you can also again expand your PRAESENSA system. So this could be also a way to interface. Yeah, not all PRAESENSA network requirements now apply for the customer IT network. So as long as it's just only used for remote monitoring, management and configuration. So that's still possible. Well, yeah, the exception is what I mentioned, the firmware upload, but furthermore to manage your devices, to do reconfigurations, etc. That can all, and to log, to do logging, etc. that can be done through your remote network. So that's not an issue. No critical audio, and that same applies for this. It should go through the customer IT network as long as you do not have any certified switches in it. So interconnect through a customer layer 2 network. So now I have two connections, two layer 2 connections, no gateway or router, the customer IT network in the same VLAN, and in this case, the customer IT network must comply to the network requirements. So now this chapter 4.6 really applies. If you have here your own switch, where you go when really audio goes through that network, now this must be comply like with the right proper quality of service with all the, because the real audio gets from this port via the customer network to the system controller, for example, and the amplifier. So now the IT network must comply to these network requirements. And critical audio and control paths through the customer IT network might require the certification. So for monitoring, it is not applicable. Huh? So if it just you use the customer network to monitor the PRAESENSA system and to log the PRAESENSA system, that to run a logging server, that's not something which is then mandatory to comply to all the statements in chapter 4.6. But as soon as something like this happens, when you have really critical audio going through 1 to B, then it applies. Here we have this layer 3 network with router ports. Yeah, when you are now we have talking about a multi-subnet system, and it's not only for connecting to a customer network, but also in case you would say, I want to segment my PRAESENSA system into multiple subnets. Yeah, then you need to have some additional hardware. That's the RNE. And that is a device which supports then to run the system over multiple subnets. So that's something which will also be discussed in a separate session. Customer IT network must comply to the PRAESENSA network requirements in this case, because we are here now having also that RNE, and so we must in that case manage the control properly. So critical audio and control parts again might require certification in that case. So yeah, here we have also direct SFPs. You can see these connections. We can have direct fiber connections from here, for example, here to this switch. So yeah, if your infrastructure in the building allows to have also direct fiber connectivity, that's even better. And then you can create your own dedicated network for it. So it's keep in mind that all our devices have already a switch inside, so it's you can pretty much do already with the equipment itself. You don't always need directly to run through the customer IT network. So only if it's really required, then consider these things. We see also solutions with the PRAESENSA system using MPLS or EVPN, wide area network technologies. I've seen them from Cisco, for example. They could offer a layer 2 connections over a layer 3 network. That would mean that it looks like here on the distribution layer, it's all IP, it's all layer 3. And then at the access layer, they offer like it is one and the same VLAN. So that's we have already successful implementations, even in an airport, where this works perfectly. So it is possible, these technologies. So then you do not need to work with these RNE or these kind of things, but it requires high knowledge on how to set up such EVPN VPN network. And we did not test it from the Bosch side itself. It's then something which is really on the responsibility of the network provider to solve this solution. So it is possible. At least we have seen this working in situations, but it's not something which we fully service from Bosch side. Yeah? But just as a consideration. Here we have an interface example of an OCC operation control and a backup control center, where we have a control VLAN and a Dante VLAN. There the control centers have standard Dante out, and we have separate subsystems here. That's also an option. We have a Dante gateway, which can transfer from an external Dante network audio into the dedicated local VLAN in a subsystem. So you can do your layer 3 management directly via the control network, and you can use this gateway then to bring the standard Dante from the central into the local network. In that case, the advantage is also that you do not need to have Dante domain manager, but also still have the option. If you say also the central Dante VLAN consists out of multiple networks, then you could also do that. So, but at least in this case, it are really separate networks here, and you can do that with this Dante gateway. That's one of the interface options here as well. Yeah. Another option is using the gateway in combination with Dante Domain Manager, what I just mentioned, so that you have this central Dante VLAN here on top, and you have then multiple VLANs going to the different gateways. Yeah, so that's also an option to do. And we have a third option where we are using multi-controller in combination with ARNIs, and then these ARNIs get into the picture. And these ARNIs then, and now it's all just one network where we connect to. And then if you have your OCC with the control and Dante audio network as one network, your example is VLAN 1 here mentioned, and then this audio will be now not directly connected to the local system controllers, but the audio will be connected to the system controller at the OCC and BCC. So the backup control center and the operational control center, and there they can from there route the audio from within the PRAESENSA system to all the other systems. So our Omnio network infrastructure supports to go over multiple subnets and can then address the audio into the local substations. So then you do not need to have these gateways. Then it's just one and the same Omnio network, which then from here, from the system controller, will address that audio to the different stations or buildings, whatever you have in your application. Yeah.
Okay, thank you, Anton, for this presentation. I would like to thank you all for your participation. I hope you were able to enjoy all the 7 sessions that we had. So altogether, I think it was a decent pack of IP knowledge that we transferred to the audience. In case you want to review it, everything is recorded, so you can still go through all of the sessions to listen one after the other. And once again, thank you for the participation. Anton, thank you for hosting or presenting all of these great webinars. And then I wish you a very good remainder of the day. Thank you very much.
Yeah, thank you very much.